we'll go through basically the training. We'll go through the process description, the actual chemistry and the biology of the sewage treatment briefly, just so you understand why the system works the way it does. Then we'll go through the installation of the treatment tank, the installation of the components, low air alarm, and we'll go into some of the wiring. Then we'll get into the startup operation, troubleshooting and maintenance. We'll go kind of march through this training manual, and there will be opportunity for you guys to ask questions as we get through it. So basically what we have to start with, we'll just kind of go through this treatment system is comprised of a 3-compartment treatment tank, and this is basically a real good old-fashioned aerobic treatment digester. And there's a lot of these types of systems down in the south and the southeast where they have simply a chamber where they blow oxygen into it. And not always do they have a trash chamber ahead of it, but if you could picture this guy being a 2-compartment tank under a normal circumstance, they'll blow air in there, and the air will just mix, digest, and they'll go through a clarifier. And down south, what often they'll do is just go through a chlorinator compartment, and then they'll run a sprinkler out in the yard, or else dump it in the ditch.
I've heard some of that.
There's a lot of those systems like that down south, Mississippi, Louisiana. There's a lot of poor soils. Basically, they're down in the swamps.
Yeah.
They can't do anything else. They do their best. They've got this NSF standard 40 that they meet. Well, the EnviroFlow is the parent company of NuWater, and they came up with the first NSF approved system in the state of Mississippi, and that comprised of a 3-compartment tank just like this. But they ran an aerator in the first compartment and an aerator in the second compartment, and that gave a real good treatment system for them. Well, for the state of Washington, they came out with a system called the bioaerobic system. Previously, the NuWater system was called bioaerobics. And they had a trash chamber that was not aerated. They just basically had a septic tank compartment for pre-treatment, then they had a digester, then they went through the clarifier, and then after that, to meet the standard, they had to put a UV light. Usually that was on the inlet of the pump chamber. So that was the bioaerobic system, and that was in place from 2008 to 2012 approximately. And there was a bunch of those that got installed. But the manufacturer, the owner of the company, was a fellow by the name of Joe Lacey. He kind of kept tinkering, kept inventing, and he came out with a system to meet the nitrogen standards. He came out with a system that would denitrify. And to do this, he came out with, and nitrogen is a big problem in certain areas like Puget Sound, Thurston County. There's these areas where they have these nitrogen blooms and oxygen die-off, bacteria, they have these algae blooms. So what he came up with is a system that could treat nitrogen. And he built it into his same tank. And this system has a pre-treatment tank, the digester, and the clarifier. Now, typically for nitrogen is something that's common in our waste. You've heard of nitrogen, it's like fertilizer, right? It's a component of our waste. But a typical septic tank, you go through a septic tank and you basically are creating from organic nitrogen, you're creating ammonia and ammonium. And that's that, you can smell the ammonia gas, that methane gas smell. That's typical septic tank environment. You will treat that. The bacteria will convert that organic nitrogen to ammonia and ammonium, and it'll go out suspended in the waste into the ground. And in an aerobic environment in the ground, which is, there's air available in the soil, right? Yeah. The bacteria then convert it from ammonia and ammonium to nitrate and nitrite. Oh. So if you pull a sample out of the D box, out of a septic tank, it won't have high nitrates, it'll have high ammonia and ammonium. Okay. But then in that aerobic environment, in the soil, it converts to nitrate. And that's the bad stuff. Yeah. That's why all these systems all around Pierce County and Thurston County, they have systems, even though that are working, they'll ammonify in the tank and they'll nitrify in the soil. And it gets down in the Puget Sound, and then it's a problem. So, same thing in Massachusetts, these other places that have nitrogen problem. So what they've done is he created a system where we take this trash chamber, that's like our septic tank compartment, and we give it pre-treatment. Our pre-treatment creates this ammonification. So we're ammonifying the organic nitrogen. Then it goes from there into our digester. Now we're mimicking that same thing that happens in the ground where we have aerobic bacteria now available to convert it from ammonia and ammonium to nitrate and nitrite. It's happening in the tank, yeah. So this is now just like what has happened out there in the soil is happening in the tank, but now we're keeping it in the tank. So the third process, or the third step, we need to denitrify. So we have nitrogen it goes from organic nitrogen to ammonia to nitrate, and now in order to denitrify, typically a sewage treatment plant will have a anox tank, and they'll add a what they call like a carbon source for food for the bacteria to pull the oxygen out of the nitrate and nitrite. So what Joe decided was, let's just create an airlift. Let's create an airlift and recirculate some of our sludge back to our trash tank. And so what we did is we took this blower, which is the same blower essentially as the old bioaerobics blower, but we put a computer in it with a dual port outlet with a timer inside here that once a day we're going to turn this skim cycle on here. You can see it says main and skim. The skim cycle will turn on once a day, middle of the night, and recirculate the sludge back to our trash chamber. Now that sludge is full of that nitrate and nitrite, but now it's gone back to an area where there's no oxygen. The bacteria are accustomed to having oxygen, right? So they'll actually steal the oxygen molecules out of the nitrate and nitrite, and then the nitrogen gas just vents back out through the plumbing. So that's created a system that is efficiently and cheaply denitrifying. There are other systems out there that have various ways of doing that. They may oxygenate for a while, and then they'll turn off, turn back on, turn off, that kind of thing. What we've done is kept the blower running all the time, and we're recirculating the waste back. Now, it meets the NSF standard 245 for greater than 50% nitrogen reduction, but that's not the big thing for us. The big thing for us is this process, by doing this, has created such an efficiency in the bacteria that the bacteria really thrive. And this is an unintended consequence of this invention, surprisingly. But now we have a typical waste stream coming into an aerobic system, which under a normal aerobic treatment system, you have surges. You have middle of the day, evening surges, weekend surges. Our daily sludge return creates such a stability in the system that once a day we're recirculating the sludge from the digester, we're vacuuming it back through the trash chamber. It recirculates some waste back into the digester again. The bacteria are always getting fed on a daily basis. They're getting a replenishment of all their food source. Okay. So now what we've created is this bacteria colony in here that's always fed. You can picture a healthy anything. The more often you feed it, the bit more healthy, more vigorous it is. I liken it to you picture the guard dog on a chain. You feed it little scraps of meat and it's always hungry for more. Same thing with these bacteria. They're always being fed just enough, and then every day this digester shuts off and this sludge return recirculates the sludge back to the trash chamber, and it pulls their food out from under them, but then it feeds them a little bit more by flushing some waste through the trash chamber. Now, basically, if we could follow the steps through the system, we take some waste into our trash chamber. We're getting a pre-treatment here, and if you flush a gallon or two into the system, it's going to displace some water into our digester. Our digester, under more than 23 hours a day, is rolling, mixing, agitating. The air coming through this diffuser in the digester is wanting to rise, creates this rolling action. If you look down through that lid, you'll see the water moving sideways. It's actually coming up and then over. So it's rolling just like that. So you flush a few gallons into there, it'll displace a few gallons into the clarifier. And if you can picture this cloudy environment in here, it'll displace, you can picture that cloud of waste coming in here for just a few gallons. There's going to be oxygen bubbles mixing in with that. The oxygen bubbles will rise to the surface, they'll burst at the surface, and then the attached solids will settle back down. That's the reason we have a sloped surface here. The bottom has a slope that allows that solids to slide back down and get whisked right back into that rolling action. It just pulls it right back in and it gets it mixing back up. So by the time You displace some water through here, it spends 8 hours on average for a 4-bedroom system in the clarifier. Now what's happened is, with our lean, mean bacteria colony in here, these guys have always been well fed, right? Now you displace a few gallons of water into that clarifier, and the bacteria now have to spend 8 hours in an environment. If they're going to make it out there as bacteria, which the bad bacteria are like fecal coliform, they're going to have to spend 8 hours here with no food. And for them, that's a long time. They've always had food in their digester because they've sat in here in their whole lifetime. So now for 8 hours, they're sitting here and slowly they're making their way towards the outlet baffle. So what happens is they cannibalize. They start eating one another before they go out. And that's how, this is an unintended consequence of this design, but we were able to get this system to treat the fecal coliform as well as the BOD, the TSS, that's the biological oxygen demand, total suspended solids, and the nitrogen. But we were able to reduce the fecal coliform to meet this threshold for treatment level B, which is what would normally require a UV light. So that's kind of this process behind and the science behind the actual installation and the tank. And so then we'll kind of go from there into this following along with the training manual.